Hello there, welcome to the second part of my developer journey on vblog. So I have my coffee ready, and yeah, we're gonna continue the project. What I want to do today, so basically I have all the code in one random branch, so I want to push that to main, and first do a little bit of refactoring, and then we're gonna write some more, let's say, I don't want to say production ready, but more polished training code, and maybe do a little bit of design behind where we want to place the files, etc. So I'm gonna, I guess, remove my webcam, and yeah, so yeah, I have my display here. I'm gonna minimize this. Yep, let's go. So currently all my code is here on this branch. I don't even have a git in your file for Python. So I guess we can start by adding that. So git in your Python. Let's get the row and let's download it. Oh man. How do you Mac? Output file, okay. Oh, not git in your. We have it. Git in your. Where is it? In this folder. Okay, cool. Now we want to add some lighting stuff. So I guess we don't want to place these lighting logs that I have no idea what this thing is. And let's also, yeah, so git status, git in your, and let's also add the playground train. Just playgrounds. Let's put all these bad boys here. Nice. Playgrounds. Sorry. Git commit IAM, added git in your, and move playgrounds to git push. Let's go. Now we're gonna merge this to main. I think should be able to see a pull request. Sorry. I don't have a main branch. Oh, lol. Git be main. Git checkout branch main. Okay. Git push. Yep. Okay, now we have a main branch. Sweet. Okay, it's already up to date. So I guess in general, where is main branches? Default branch, no. To main. Default branch to consider base branch. No, I want to move it. Update. Sweet. Your main branch isn't protected. Yeah, now I can go ahead there on the main branch. Right, git branch D feature loss, right? Push. Yeah, but I want to remove the remote one as well, so I guess origin. I don't remember. I'm just gonna do that from here. I'm a terrible developer. Feature loss. Bye bye. Okay. So now basically our project looks like this. So we have source folder, an end folder in which I have some classes. So I have some common. Common in reality doesn't really means too much, but we're gonna keep that for now. So I have this code got a copy from the clip. Basically, I guess it's an approximation of the Galu. I guess it's supposed to be quicker. Then we have a com norm Galu layer in yeah. So I was not able to use the from Torch Vision dot and I think it's oops import yeah. So in Torch Vision they have this that is quite handy. The issue with that is that in the norm layer they are gonna expect yeah, so they're gonna pass by default some stuff I don't want to, since I want to use a group norm, right? So this should be called group norm. So let's go ahead, group. Yeah, I mean this is in reality layer norm. Com layer norm Galu. Yeah, because crop norm with groups 1 is the same as layer norm, but works for 2 data. Sweet. So I'm just gonna ahead and replace them. Yep. And same thing here. 2D. And same. Yeah, you know, I'm just gonna stay with 2D. I think for consistency with PyTorch. And we are ground transpose on Galu, and we're just gonna do this. Yeah, okay. Yeah, but we should have a. Okay, this is just gonna be a refactor feature. It's not gonna be a feature. It's gonna be a refactor. Okay. Yeah, makes sense. Do we have black installed? Yeah, why am I sourcing? Sweet. We don't need this, and we don't need this. I should link my code. Yeah, who cares now? Like it. We have isort. Yeah, so let's go pip install isort. Sort src. Sweet. Okay, then I also have a functional. Here I have window partition that basically is gonna partition. It's gonna take tensor of batch 8 width and channels. 8 width and channels. It's interesting. That's interesting. This is using my transformer block. Yeah. I need to check for that. This was original code. Don't care. We're going to return a tuple of a tensor. Then this is the pad height and weight. So how much we pad, basically, and then the original height and weight. Okay. So here we have a tuple int, tuple of int. Tunes. Nope. Let's fix this terrible documentation. Yeah, so if we look at our types somewhere else, maybe in the head, yeah, I follow let's say Hugging Face way of writing the doc for the tensors. That is way better in my opinion. Input tokens. So let's be consistent, and I use the capital letter. Input tokens. If this is kind of incorrect, right? Because if these were the input tokens, then we would have the channels here. Now we have the channels here, but this will be the sequence length. So maybe let's add a note here. Note. Probably we want to pass a tensor of times width, right? So this will be the sequence length. Yeah, the target window size. Okay, tensor of shape. So this will be tensor of shape, number of windows. Of course, window size, windows after partition. Before partition. This is not true. This is not true. I think I need to double check. Double check this. But we can still update the docs. Yep. I think my notation, yeah, was something like that. Here maybe, yeah. So yeah, still I need to recheck the eigenface notation that I'm used to. Original height and weight. Yeah. This is before the partition, of course, because we before it. We partition before it. Yeah. So here, yeah. So this makes sense. This makes sense because we need to pass it height and weight, because we need to use the height and weight. So let's remove this. Here I'm doing some cleanups, and to understand it, we need to call the continuous every time with your view for optimization reasons. Window and partition into the reasons sequence and removing inverse of window partition. Okay. Input opens. Input partition made window size, padded height and width. Yeah, I removed that. Yeah, like I'm just using this size. Unpadded size. Yeah. So this will be the size before we pad, right? So here we are padding, that's right. Pad. Do I need to use this one? I'm not sure. So let me check. So this code was borrowed from VAT Detectron 2. So I need to go here and this repo is startable. Backbone VAT. No, they are returning this. Yeah, this is the original. Yeah, before padding. Yeah, I don't need that because I'm using ANOPS. Yeah, so you know, you see I don't need to also have the padding, height and width. Before padding size, let's keep variables meaningful name. Before padding. Tensor of shape. Tensor of shape. Pew. Height. Width. Sweet. Okay. Here I have a little test that this one is going to work. Too many values to unpack, expect 2. Yeah. Because we have padded height, size, original. It's not size, is before padding size. Oh. Yeah, I mean, I will write the test later, so this is just to see that it's running and doing something. Right, sort. Oh no. Then we're gonna add Makefile to do this automatically. So yeah, so here I have this, then this is an adapter that basically takes the output from a VAT. Here we have VAT, this VAT specifically, we're passing by reference. Away we get the features from the VAT, and for each feature we rearrange it in a CNN form. And yeah, then we need to use the input resolution divided by the pad size. Yeah, so this is a big issue, right? Because we are assuming that they're always going to be the same, but to me this is a good assumption. If we want to work with smaller images, that's gonna be a little tricky, but this is fine for now. In types, I have a file types. I'm gonna create also a class. That's gonna be features. It's gonna be a list of tensor. Right. From types. Import features. It's gonna be a list of tensor because we are returning a list of tensor. Okay. Now we have this feature pyramid network. These parameters are not used. I don't like this name here, but we're gonna stick with that for now. So here, you know, it's taking, yeah, so let's go ahead and use our type from src.types, import feature, remove stuff we don't need, and remove this guy. So this is simple FPN. It was proposed on a paper. I need to add the doc another day and only use the last feature. Sweet. It would be good to do this in parallel, to be honest, because here we are doing them sequentially, but they don't depend on each other. So yeah, it would be good to do them in parallel, but I don't know how to do it. Then we have our head here, and our, oh yeah, okay. There is some stuff going on here. We have a scale layer that basically apply a scale to a parameter, and this is used in the FPN to scale each feature. It's a learn parameter. Then we have this thing that calls stack 2 2D layers, and basically this take a com layer. And stack them. So this is my opinion. Should go in the comment. From scs.nn commons import stack to this layer. Sweet. Yeah. Not true. It's in a layer here. Come on. So okay. Okay, here I have some comments. You know, this is basically refine one net. Refine head from this implementation here of one net. One net transformer class, you know, it's not. This is not true. This is not a one net transformer class. So I'm just gonna. I need to install an extension docstring. Python docstring. There we go. Copy it and adapt it from one net. And let's put a link here. Okay. From src.types import features. Okay, so here is doing a bunch of stuff. We don't need to worry about that. This is a tensor. This is a tensor. And this is a tensor. I don't want to change features. Yeah. Okay. This. I don't need this anymore. We are not using any relative import here, so this should run. Interesting. Python. C head. No one will be able to see, yeah? Not sure, I don't care. Let's have a look at the loss. Yeah, okay, so basically, yeah, okay, so one thing at a time. Matcher. Yeah, we need to decide what to match. Okay. Okay, until save profile on CUDA. Yeah, this is convert weight floating point 16. This was copied from Clip. I don't think we need this. Don't need this because in PyTorch we now have some sort of list for floating point 16 that tells which operation can be converted and which cannot. This is the VAT from Clip. And I'm not using their layer nom anymore. This should work because layer nom can handle. I mean, won't be autocast. 2.16. If you use the mix and precision decorator, Then I had the drop path probabilities ratios here, I think they're called, drop rate, and this is stochastic depth. But maybe I want to call drop rates. Yeah. Yeah, so basically here what we're doing, we're setting a drop-off rate. Then we create a list pane from 0 dot rate using number of layers, and then to each layer we add one of them. The reshape copies the data. I'll go with view. Let me check view contiguous PyTorch. Taking a view of a contiguous tension quickly, okay. Reshape PyTorch generate contiguous tensor. Let me check. Well, fuck it, I'm gonna keep it. Okay, so one thing that we want to do. Okay, so here in my VAT I'm skipping the class token. It's not used. It's not used. So yeah. Because we just need embeddings. I also this enterprise position encoding. Okay, so what I think we need to do is to add I wonder if I should add FBN head Yacht name refer model VAT to NN. So one thing for sure I want to do object. So here in taskis, I'm gonna separate for object detection. So I guess I'm gonna take the loss for object detection there. I'm gonna take the head. Yeah, this just should go in object detection. I'm gonna take the head, right? Nice. And I guess the matcher. The matcher is, yeah. Let's put it here. And then everything else I'm gonna place it inside neural networks. Why not? SPN, path, VAT, Yoto. Yeah, and then you know what? We're also gonna create a data, and we're gonna place something there. Do we have any init here? A. What's going on here? Why I can't open? What's going on? Okay. Yeah, that's weird. It's marking the previous files as deleted and not move. So if I move this here, what the fuck is going on here? Modif. There is something wrong with Visual Studio Code. It should be modified. Untrack. Fuck it, git add git commit editor refactor and move files. Yeah, what's your name? We have 3 installed here. Okay. Yeah. Where is Miracle? Okay. Yeah, I'm gonna merge it. Now the thing I'm thinking about is naming. Right, so should this be named? So here in my original implementation I have this thing that is called task, in which I pass a model. Right, so now what I believe will make more sense, and if you see a model, if we go to Yoto, that I place it here, I have Yoto basically takes a backbone and the neck, right, and do this, and then I have Yoto for object detection and takes Yoto and a head. Now this in my opinion is kind of dumb, but it's not dumb. It's just a matter how much I want to separate the model to the training code. Now since I don't want to think too much about this and I'm lazy, I think I'm gonna change this to modeling and place this code inside this thing here. and updating the forward. Why not? So let's open an issue. I'm gonna say lazy link, coupling, modeling code, and training code. Motivation. So yeah. Currently, the model Yoto is not coupled, aka coded inside a lighting model. Since I am lazy, I think it will be faster to just change the folder task to modeling and add a Yoto for object detection inside directly inside lighting model. Why not? I mean, I'm going to train for object detection, right? If we need more decoupling and or today is not the day to think too much about design. Why not? Status. Okay, let's do this. Git checkout p feature hashtag 6. Models. Okay, what we're gonna do inside here? What is wrong with this thing? Say, come on. So like this is the base model, right? So okay, so let's create a subfolder. It's called Yoto. Place it all this stuff here. Why I have two losses? Everything is here. Yoto for object detection. Let's yeah, this is kind of broken. Let's import this multi-screen. Loss. Sure. So what we need to do is, yeah, the important thing is I keep these names here. because if I need to change something in the future, I can just go ahead and restructure the the tensor dict, the state dict, right? Yeah, you know, I think I'm gonna keep this. Fuck it, I'm just gonna pass everything. Come on, backbone, neck, blah 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 blah. Head, let's fix the type. Head from head import head. Come on. So that's the type that I'm expecting. Yeah. So this is my answer. Yeah. Bye bye. Okay, so this is the main issue, right? So in this case, it will make more sense to create everything from here. So have one big config, flatten configuration with everything on there. But then it's gonna be hard. So like here, you know, I will just have everything I need to create this backbone, the neck, etc. But then it will be fixed. Now this is bad because what I need to do, yeah, okay, so edit art 1, having everything inside I think module will force me to pass all the parameters to create the model itself, making it impossible to swap around components later on. And what I mean by this, by it is that if I have everything here, I'm just gonna go back to the original one. Nope. Okay, then I mean, for the name is not really important. I just move around. I just need something that is good, well organized. Okay, so yeah, I can just create a model by passing it with a component, so it's easier to swap them, and then I can just have a auto projection class. So now the main issue is that I'm focusing yeah, fuck it. I'm just gonna, this is a task. So the issue is I want to have the train code decoupled from the model. I can create a model and then I pass to the lighting module. This makes it easier later on if I want to change the backbone. Assuming that I can do the same thing, right? I can have all these things here, but then like to create the head, I need to add the number of classes that I'm passing already here. So at that point, so what's the point of passing something here? I need to create. At this point, it will make more sense that I pass the loss as well. But then, oh yeah, fuck it. Yeah, but then assume I pass everything inside. If I pass everything inside, so the backbone, the neck, the head, and the loss, then this is only task dependent, right? Inside my training step, okay, edit one. I could pass the loss as well to the lighting model. This will make the task model independent, but I guess it will require the model and loss to work properly together. Okay, trusting each other's outputs. You see, because since we're doing object detection, we know what we will from the auto of object detection. In inference mode, will return bounding boxes. That's it. So since they will return bounding boxes, the inference, like the test and evaluation, it's okay. It's model independent. We always see the bounding boxes. But yeah, fuck it. Let's do one net loss in Yoto. Yoto for detection. Here's somewhere I have a train playground. Okay, now the thing that I'm thinking about is just clear the object detection. Delete. Multi-decimal focal loss. All right. Contact types. And then I have this task here. Is that right? So this will just try to run on one random batch. Oh, yep. Import sys dot I think this is called from this folder. Yes. Let's check it. Yes, model. Okay, sweet. Now we have done a little bit of weird stuff. Oh, what was training? Training. Latte. Let's try. Okay. It's training. Okay. So our loss is going to return a dictionary. Now I want to recheck in the original implementation of OneNet. Let me update. Model will have to return something. Because the main issue if of having this one with the model inside. So I could have everything here. I could just pass the model, the neck and the backbone, right? Have everything here and having the forwards here. At least this is, here we have all the training code, and there we just have the modeling code, so it's easier, I guess, for me to forward. Yes, I need to out. Do I have something called inference here? No, I want to very quickly check the OneNet. I want to check the OneNet loss function. It's what I use him heavily changed, but I just would like to check. Okay. Then I guess in the model is the model? Train net. Yeah. Don't care. Oh, wait. Decon detector. Here we go. Hold the sheet. Okay. Don't care. Inference. Yeah, see in the inference. Yeah, we're going to use the same one. So from the head we are doing class logics and bounding box predictions. Class logics, bounding box prediction. Yeah, sweet. Okay. Okay. Now I don't remember one thing. It's conflict. Reduce Python. Oh. What in well, I mean, I could just return a tensor without this free and just to the mean. No, I mean the sum, I guess. I can return a tensor date. Well, for now this should do. The only thing that so I need to put a breakpoint here. So let's check. To check the gradients. I like the gradients node there. Dot loss. Okay, cool. I could just do use work. Yep, work well. I'm not sure how many variables in the middle it's creating, to be honest. Another way would be plus. Yeah, you know, I think this is perfectly fine. It's more readable. Reduce loss by summing. Now, in the loss function, yeah, We have the loss, we have the forward, we have a little optimizer. Not too bad. Not too bad. Not too bad. The learning rate. Now in lighting, what would be the perfect way of passing a configuration to that bad boy? What the hell is it starting? Okay. What would be hyperparameters? Oh. Yeah, learning rate. Okay, I mean with the learning rate. Now I want to set up a little bit of little bit of more scheduler. So in the original and this implementation, but I will do a VAT edit. Let's go here and have a look. Okay. Yeah, we're going. Yeah, of course. We don't care about this. Adam W. Oh, let's use that. Adam W. Come on. So we have a warm-up learn rate schedule. What does it? That takes. Okay. Lightning. And let's look for scheduler. Let's have a look. Alright, scheduling. No, this is a low level. Okay. What the fuck is this thing? Last time I checked, it was inside the configure optimizer. I need to. Where is the source code? It's the license CLI. I don't know. Let's have a look. Cool. Nope. I think we want what is the thing? Interesting. So yeah, T should be for another issue. T should be for another issue. T should be for another issue. Okay, it's times. Okay. Switch main. Okay, cool. Now we were saying that they use let's just open one. Forward figure. No, we were talking about this one. Warm-up parim schedule. And then they have these things. What the hell is this thing? composite param schedule. We can just use the warm-up cosine schedule, who cares? And our schedule is nice. So I guess I can just copy this. Fuck. FBB core, what the hell is FB core? Okay, I don't care about this. Common, where are the scheduler? Transistor. Okay, ho capito. Where is the source code for that? Cool. Why is step operator? Okay. I mean, it's not like I need to warm up so much since I'm just fine-tuning basically the neck, just trying the neck they had. But it would be nice to understand where this thing is coming from. So they have this warm-up param schedule. What the fuck is this thing? Wait. This is some sort of factory class. I want linear, so linear param schedule, start, end. A scheduler is a param schedule. Okay. And then, okay, makes sense. Cool. Yeah, so I can stop here for now. I will continue later. Cool.